Hello everyone, welcome to the presentation of our paper titled Shadow Art Revisited, a Differentiable Rendering Based Approach. In this work, we try to explore the potential of using differentiable rendering to create artistic 3D sculptures which cast mind-boggling shadows when lit from different directions. This form of sculptural art is known as shadow art. Now in past, various artists have created such shadow art sculptures. Like this one from the artist Kumi Yamashita. It looks like a question mark from one side and an exclamatory mark from the other. Then we have the famous aquarium of floating letters by Shigeo Fukuda, and even the famous book cover by Douglas Hofstadter. Now the question is, can we design an algorithm to create such artistic 3D sculptures? This is basically the motivation of our work. We try to generate a 3D sculpture S that casts n target shadows when lit from n different directions. As shadow is essentially a projection on a planar surface, we assume that finding the shadow of an object is equivalent to finding its corresponding silhouette when rendered from the same direction as the lighting source. Hence, the shadow art problem is similar to a multi-view 3D reconstruction problem where we try to estimate the 3D structure of an object given its n still-out views. However, in case of shadow art, the learned 3D sculpture may bear no resemblance with any real-world object. So basically, our objective is to find a 3D shape S such that the difference between the rendered and the corresponding target silhouettes for each view is minimum. This is where differentiable rendering plays an important role. Unlike classical rendering, differentiable rendering enables us to propagate errors from image domain back to the parameters of the 3D shape that is being rendered. In other words, it enables us to iteratively update S. Hence, in our pipeline, we can randomly initialize the 3D sculpture S, render its silhouettes from n different directions, and iteratively optimize S to reduce the error between target and rendered silhouettes. We use the differentiable silhouette renderer provided in PyTorch 3D. In our work, we choose two different representations for S, mesh-based and voxel-based representation. In case of mesh-based representation, we initialize S as an icosphere, and during optimization, the deformation to be applied to the icosphere is learned. In case of voxel-based representation, we initialize S as a cubic volume consisting of discrete units called voxels and optimize the density value for each voxel using a voxel-based differentiable renderer. Voxels with density above the threshold are retained and rest are removed. Here are some results of our mesh as well as voxel-based optimization pipelines for different shadow configurations. We also simulate the artistic effects that the optimized sculptures are capable of generating using Blender. We compare the results of our voxel-based optimization pipeline and voxel-based optimization tool presented by Mitra et al. The error is represented in orange pixels. Our method generates more accurate shadows even without applying any form of deformation on the target shadow images. Here are some additional shadow art creations. A seemingly random soup of voxels creating three distinct shadows resembling sketches of minions. The WACV acronym on one plane and fishes on the other to resemble an aquarium of floating letters. And finally, shadow of heart, duck and Mickey all on the same plane. Another interesting extension to our work is towards sketch-based modeling, where we use hand-drawn sketches of a shape from different viewpoints to automatically create the underlying 3D object. Finally, we demonstrate the physical realizability of our method by 3D printing some of the resulting sculptures to generate some real shadow art effects. Thank you very much.